Hey students, Mr. Martin and his chaotic iPad with a low charge is back. For this part of the video, we're going to go over verifying identities. We're going to use a Pythagorean identity with some other tricks. All right, so I don't know which way you work this. There are a couple of ways to verify an identity. In my opinion, the easiest way for this one is we're going to use the identity tangent squared x plus 1 equals secant squared x. So now, and what we're going to target is this replacement here, secant squared. So now, secant squared is tangent squared x plus 1. So we're going to rewrite this to be 1 minus tangent squared x plus 1 divided by tangent x. Remember, on the other side, we don't actually touch it. So then that's going to be 1 minus tangent squared x minus 1. The 1's cancel. And so again, that's going to equal supposedly still negative tangent x. So we end up with negative tangent squared x divided by tangent x. Now, you know, anything squared is just itself times itself. So negative tangent x times tangent x divided by tangent x. So the tangents cancel, and we actually end up with negative tangent x. So that's one way to do it. You may have done it a different way. As long as you mathematically got here, you are correct. Number 10, 1 over secant squared x plus 1. Let's see. What would Mr. Martin do here? There's a couple ways to do this. Let's be clever. So secant squared x plus 1, do we have an identity for that? No, we don't. Secant squared is tangent squared plus 1, so that would be tangent squared plus 2. Easiest thing to do is then turn everything into sine and cosine. So in this case, we're going to turn everything into cosine. So we get 1 divided by cosine squared x plus 1. I'm sorry, that's not correct. Mr. Martin, you lied. Is 1 divided by 1 over cosine squared x plus 1. So 1 divided by 1 over cosine squared x plus 1. And so now that's going to equal this thing on the right, I'm sorry. So if we get a common denominator, that means that we need to multiply by cosine squared in the numerator and denominator of that fraction. So we get 1 divided by 1 over cosine squared x plus cosine squared x over cosine squared x. And that supposedly still equals what we have on the right. You keep going a bit, and so you get 1 over 1 plus cosine squared x divided by cosine squared x. And everybody's favorite thing to do in math is flip the fraction over, do the whole keep, change, flip. So that means we end up with just cosine squared x over 1 plus cosine squared x equals, isn't that what we were going for? Yep. So we go through the tunnel and we got there. Fantastic. Number 11, tangent squared divided by sine squared equals tangent squared plus 1. Let's see how that works out. So I would immediately turn tangent into sine squared x divided by cosine squared x. So tangent squared is sine divided by cosine. So sine squared divided by cosine. And so we're still dividing by sine squared x. That's going to equal, supposedly, tangent squared plus 1. So we can multiply this and turn it into sine squared x divided by cosine squared x times sine squared x, and the sine squareds cancel, so we get 1 over cosine squared x. And we know 1 over cosine squared x is actually equal to secant squared x. And what is secant squared equal to, kids? Right here, tangent squared x plus 1. So we get tangent squared x plus 1 equals, oh, we didn't draw our little tunnel so we can drive through it. Not having any fun. So now we drive all the way through the tunnel. We got back where we started. Hey. Number 12, secant x divided by cosecant squared x plus secant squared x equals sine squared x times cosine x. This is a good candidate to turn everything into sine and cosine. So we're going to get 1 over cosine x. Let's change the thickness of this since I'm zooming in. Go down here. All right. So 1 divided by cosine x, and all of this is going to be divided by 1 over sine squared x plus 1 over cosine squared x. Cool. So common denominator, we'll at this point, I'm sure you know we get cosine squared x plus sine squared x divided by sine squared x cosine squared x, and all of that is under 1. So we turned this denominator into that denominator. Cool. So what we get is, oh man, did I leave a square out here? So we get, yeah, I did. I'm sorry. If you were struggling with this, that's my bad. That should be sine squared x cosine squared x. My apologies. So when we do the keep change flip, we're going to get sine squared x cosine squared x over, oh, Mr. Martin, you tripping? Nope, I take that back. I forgot the Mr. Martin's tripping. I forgot the 1 over cosine thing. Mr. Martin, you crazy. So nope, take it back. I'll take it all back. Nobody's perfect, you know, except for Rihanna. So 1 divided by cosine x. So we get sine squared over cosine squared x times cosine squared x plus sine squared x. That's the flip part. And so that still needs to be multiplied by 1 over cosine x. My apologies. So now sine squared plus cosine squared equals 1. So we get sine squared x plus cosines. Nope, that's multiplied. Mr. Martin, you not with it today. So my bad. So we get sine squared times cosine squared x. And again, this equals 1. Sine squared plus cosine squared. So divided by cosine x. Now, of course, we can cancel one of the cosines. So we get sine squared x cosine x. All right. Oh, Mr. Marine, you need to make a tunnel for us to drive through. Got it. Got it. Got it. Got it. So now we say, yay, we got it. Back where we started. Cool. All right. So, yeah, that's a good stopping point for this video. And then the last one, we'll cover the inverse